Hello everyone, I am Dr. Muhammad Shoaib, and in this lecture we will study the synthesis and disconnection of 1,2-difunctionalized compounds. 1,2-difunctionalized compounds. Let's see the very simple example, that is 1,2-diketone or an alpha hydroxyketone. As we can see, there is only one C-C bond between the functionalized carbon, so there is only option to disconnect from here as shown, and we get two synthon. One synthon can be an acer derivative or aldehyde, but the second synthon is of unnatural polarity, that is acyl anion. This one is acyl anion. Remember that the first carbon, that is carbonyl carbon, is A1 acceptor synthon. So if we want to make it as a donor synthon, we want to use the process of Umpolang, that is to convert it into unnatural polarity. Let's see what is acyl anion equivalent. The simplest reagent for an acyl anion is cyanide, which is one of the very few genuine carbanion. When it is added to the aldehyde, the resultant product is cyanohydrin. This cyanohydrin can be converted into a range of compounds as shown here. By hydrolysis, it can be converted into carboxylic acid, alpha hydroxycarboxylic acid. All these are alpha hydroxy compounds. In the presence of an alcohol, it can be converted into alpha hydroxy-ester. In the presence of diisobutyl aluminium hydride, that is a reducing agent, this cyanide is converted into aldehyde. And in the presence of hydrogen and a catalyst, it can be converted into amine group, amino. As there is a versatility in cyanide ion, but there is a problem or a limitation that it can add only one carbon, but sometimes we need more than one carbon. So another alternate is use of acetylenic reagent as shown here. This alcohol can be formed by the hydration of acetylene, and the anion of acetylene acts as acyl anion equivalent. So here it is alpha hydroxyketone. By using FGI, this ketone is converted into acetylenic reagent. When it is disconnected, one is the donor synthon and other is an acceptor synthon. Synthesis is very simplest. Acetylene reacts with a base to give acetylide, particularly sodium acetylide. It is a donor synthon. It attacks on the carbonyl of ketone to produce tertiary alcohol, and in the presence of sulfuric acid and mercurous sulfate, this triple bond is hydrolyzed to carbonyl or keto group. Here it is cyclohexenone. Here it is alpha beta unsaturated carbonyl compound. Alpha beta unsaturated carbonyl compound is obtained by aldol condensation. When this double bond is disconnected, we get aldehyde and active methylene. Here is the relationship of 1,5 relationship. So it is prepared by Robinson annulation. For this purpose, we have isopropylaldehyde and alpha beta unsaturated carbonyl compound, which gives conjugate addition. And by further using FGI, this double bond is converted into this X or leaving group. If this X is equal to methoxy, then this symmetrical compound is obtained. So let's suppose that this X is equal to methoxy group, and we know that the carbonyl compound, the keto carbonyl compound can be obtained by using hydration of a triple bond. So by using FGI and hydration, this triple bond is inserted here, and this diether can be obtained from alcohol. When a carbon oxygen bond is disconnected, this alcohol is obtained, this diol is obtained. This diol can be easily prepared from acetylene and a 2 molecule of formaldehyde. Let's see the preparation. First of all, this diol is methylated with dimethyl sulfate in the presence of a base. This diether is obtained when it is hydrated in the presence of uh, AgO and sulfuric acid. Carbonyl is inserted into any one of these two carbon. It is symmetrical, so there is no problem of chemoselectivity. It is the carbonyl is obtained. Then when it reacts with isopropylaldehyde, and this in the presence of base, this negative charge on this alpha carbon will attack on this electrophilic carbon, and methoxy group will leave. Thus, this bond is formed. Then, by using aldol condensation, our required product is obtained. So here we have used the two carbon of acetylene, which is which acts as a donor synthon. Next is phenaglycodol. It is 1,2-diol. It is a drug which is used in the mild epilepsy. It can be disconnected into many ways, as 1,2-diol can be prepared by many processes. Here it is tertiary alcohol. Remember that most of the time tertiary alcohol is prepared by the Grignard reagent. So these two methyl are disconnected to obtain this carbonyl, that is ester, and then there is 1,2 relationship of this OH containing carbon and this ester carbon. So it is disconnected. So this OH is converted into carbonyl, and then it is very easy. It is a acyl group. Acylation can be easily done on the aromatic compounds. So if when it is disconnected from here, chlorobenzene is obtained. Since this is very simplest, when chlorobenzene reacts with acid chloride, then acylation takes place. In the presence of HCN, cyanohydrin is obtained. This cyanide will attack here, and then additional product will be obtained. H will be added to this oxygen. Cyanohydrin, when it is hydrolyzed in the presence of ammonia, and amine is obtained. When this amine is hydrolyzed in the presence of alcohol and ester is obtained. Then two molecules of Grignard reagent will convert this ester into our target molecule, that is alcohol 1,2-diol. As we saw that cyanide adds only one carbon, and the acetylene adds two carbon, so we should have some other acyl anion equivalent which are more versatile and which can add more than one or two carbon. So there are dithions. Here it is dithion or thioacetal of aldehyde that can be protonated between the two sulfur atoms by strong base using butyl lithium. And when it reacts with this aldehyde, this thioacetal is obtained, and in the presence of butyl lithium, this lithium hydrogen exchange takes place, and then this carbon behave as acyl anion equivalent, and it can attack to any other electrophilic carbon. When it attacks here, this product is obtained. When it is hydrolyzed, this dithion is deprotected to give us a carbonyl group. In this way, we can add as many carbon as we want by changing this R1. This R1 can be hydrogen, it can be one carbon in case of acetaldehyde, and so on. When volcanic acid was tried to synthesize, it is a substance which is used to poison the valves used by Eskimos. Here it is ketoester. Here there are two types of synthons which are obtained from one disconnection. By disconnecting from this carbon-carbon 1,2 relationship, we obtain, in fact, here it is acyl anion, and in other case this one is acyl anion. This A use the cyanide ion for this synthon, that is COOMe, and here it is some acylating agent. It is also easier to prepare by this method, A method, but B method is also very easy. It uses dithion as an acyl anion, and in the presence of a base, this acyl anion attacks on the carbon dioxide, which is acceptor synthon, and it is converted into carboxylic acid. Then this carboxylic acid is converted into ester by using alcohol, and then this dithion is deprotected or removed by using metal catalyst. So here it is our target molecule. Here it is an other alternative. Here it is alpha beta unsaturated carbonyl compound. When it is disconnected, we obtain a keto group, and here it is alpha hydroxy keto. So here it is 1,2 relationship. When it is disconnected from here, this tertiary alcohol is converted into carbonyl, and then here we have another acyl anion. This acyl anion can be obtained by using lithium derivative of a vinyl ether. Here it is vinyl ether, and when the lithium derivative is used, and this carbon becomes an negatively charged. Here it is vinyl ether. When it is treated with the tertiary butyl lithium, it is converted into lithium derivative by the exchange of hydrogen with the lithium, and then it reacts with the cyclohexanone, and this carbon will attack on this one, and this product is obtained. When it is hydrolyzed and enol is obtained, this methoxy is converted into H, and it is enol, and this enol is converted into its keto form, and then in the presence of a base and alcohol, this keto group, which is in fact the formyl group, it reacts with benzaldehyde to give the target molecule. Another method to prepare 1,2-diol or 1,2-difunctionalized compound is from alkene. If we have 1,2-diol, these can be easily prepared by the dihydroxylation of alkene. Dihydroxylation can take place in the presence of osmium tetroxide or in the presence of potassium permanganate. So by FGI, an alkene is obtained, and this alkene can be easily prepared by using Wittig reagent. Wittig reaction uses a carbonyl and a phosphorylide. Phosphorylide can be prepared from the easily available alkyl halide. But here we have some control over the stereochemistry, that is, only cis-1,2-diol can be obtained. But if we want to obtain the trans-1,2-diol or any other functional group instead of OH, such as any other nucleophile such as amino as shown here, and if both of these are trans to each other, then it is disconnected from here so that we can obtain uh, epoxide. Remember that while disconnecting, if the carbon which is adjacent to the carbon containing OH, it gets positive charge, then there is the reagent which is epoxide. And how this epoxide is obtained? Epoxide is again obtained by using alkene, and alkenes are prepared by many possible starting material by using Wittig reagent, by dehydration, by dehydrohalogenation, or there are many other methods. Here is a bistosylate which can be prepared from the diol, as these both are trans to each other, and these both tosylate can be prepared from diol. These are trans, so these can be obtained by using FGI by the hydroxylation of alkene, and this alkene can be prepared by Wittig reaction. Next is alpha functionalization of carbonyl compound. Carbonyls can be converted into 1,2-dicarbonyl by reaction with selenium dioxide or by nitrosation. For example, acetophenone gives a ketoaldehyde by using selenium dioxide, and when it is recrystallized from hot water, this stable crystalline hydrate is obtained. Here below is the method is the mechanism given. We use is the selenium dioxide oxidation. Here is another method which is the nitrosation of enol in acidic solution. Here is the nitrosation in the presence of acidic solution. It is the first step is nitrosation, which is tautomerized to give oxime, and after hydrolysis, this oxime give us diketone. So after selenium dioxide, here it is another method which converts the alpha carbon of a carbonyl into the 1,2 dicarbonyl compound. Here it is a synthesis of the drug Metaproterenol. It is an adrenaline analog used as bronchodilator. It might be used in the treatment of corona patients or something like that. Here we have amine, this secondary amine, and we know the very basic formula that the disconnected must be done from the heteroatom. When it is disconnected from here, this will be the nucleophile, and this carbon must be an electrophilic carbon. So it is converted into aldehyde, as we have seen previously, in that this aldehyde can be obtained by selenium dioxide oxidation of keto group. So next is this synthesis. When we have dimethoxy on a benzene, it is acylated to obtain this compound. When it is oxidized in the presence of selenium dioxide, this formyl group is added, and then when it reacts with isopropyl amine, and imine is obtained, which is reduced to our target molecule. Here's the last step. Because in the second last step, when we try to reduce this imine, and this reducing agent also reduces this carbonyl compound into alcohol. So by using this HBr, this hydroxyl is converted into keto group. Here it is a triester. It is one ester, and the second one, and the third one. This diester was needed to study the pericyclic reactions of electron-rich and electron-poor alkenes. It is alpha-beta unsaturated carbonyl compound. It is disconnected to obtain. It is disconnected by the use of aldol condensation. So here we have an acceptor synthon, and here it is a donor synthon. So how this carbonyl is obtained? Having diester by the nitrosation of melanoate with N2O4. This carbon is converted into carbonyl compound, and by using this phosphoracylide as shown here, this alkene is obtained. Next is another strategy which is very basic strategy, that is to use the available starting materials. There are a large number of available starting material which have 1-2 relationship There are a lot of diols, hydroxy ketones group or other groups. Here it is. We have this 1,2-diol. How it can be prepared? It can be easily prepared by using lactic acid, which is very easily available in all the labs. When this phenyl is disconnected, I have told you that when there is a tertiary hydroxyl group, tertiary alcohol, it is most probably prepared by using a carbonyl compound and a Grignard reagent. When we have this carbonyl compound, then this lactic acid or esters of lactic acid can be used to prepare the target molecule, which is 1,2-diol. A Grignard reagent can give us this target molecule RMGBr. And synthesis, in practice, lactic acid is when heated, it is dimerized. It is a dimer of lactic acid. When it reacts with excess of phenyl magnesium bromide, target molecule is obtained. Here it is the mechanism. When phenyl, which is which behaves as an anion, it attacks on this carbonyl. Then this bond is broken down. It is converted into alcohol, and a phenyl is attached to this carbonyl compound. When another phenyl magnesium bromide attacks on this carbon, then the dimer is converted into two separate molecules, and we obtain an alpha hydroxy keto group. When it reacts with another phenyl group, the target molecule is obtained. Here are some available compounds which are even present in our undergraduate lab. It is oxalic acid, it is glyoxyl, glyoxylic acid, glycolic acid, pyruvic acid, benzoin, benzyl, butadiene, lactic acid, and um, there are compounds which are amino acids. These are very diverse in nature. They both have two functional groups that are amino, which is basic, and the carboxylic, which is acid. And there are glycol 1,2-diols. There can be many 1,2-diols or 1,2-diamines or ethanol amine. Here is an other molecule which is enone. When it is disconnected from here, we obtain an we obtain a nucleophile and an electrophile. Then there is 1,3 relationship 1 2 between these two carbonyl compounds, and when it is disconnected, it is formate ester and a keto group is obtained. It is alpha hydroxy keto. We have studied its synthesis many times in this lecture. In the presence of sodium hydride, as here is no ionizable hydrogen, so this base will abstract a hydrogen from this carbon, which will attack on this formate ester, and this OET will be removed from here, and this formyl group is attached to this carbon, and when it is distilled, the required product is obtained. Then there is benzoin condensation. Alpha hydroxy carbonyl compound. If these are symmetrical, then the disconnection offers an acyl anion, which can be prepared from the aldehyde. But if the R has no ionizable hydrogen, especially when it is aromatic, so it is treated with catalytic cyanide. For example, this is benzaldehyde. Here it is no ionizable hydrogen. When it is reacted with a cyanide ion, the required product is this alpha hydroxyketone. The method is same. When in the first, the cyanohydrin will be obtained. Here is the mechanism. Cyanide reacts here, and in the first step, cyanohydrin is obtained, which is rearranged to an imine, and when it reacts with another benzaldehyde, target molecule is obtained. And that's all about 1,2 difunctionalized compounds. Thank you.